Hello everyone. In this video podcast, I'm going to record the solutions of project 3, which you're supposed to use and work through in order to prepare yourselves for test 3. Okay. Again, let me repeat that you're supposed to do the work yourselves. Solve the problems yourselves, because that's the best way you will be able to prepare for the test. However, you can always come back here and check your answers against the solutions I'm posting here. Now, we'll do the multiple choice section first. The first question says, choose the most appropriate graph for f of x equals 1 divided by 4 the whole fraction raised to the power x. Okay, so we have a choice of 4 graphs given to us, and we see that this is an exponential function. So let me pull up my pen here. So the graph of an exponential function, when the base is a value greater than 1, when the base is a value greater than 1, the graph looks like this, all right? It rises from the left to the right. And that happens if the base is greater than 1. So instead of 1/4, if this was 4 raised to the power x, this is what the shape of the graph would be, and it would be rising from the left to the right, and the whole graph would be above the x-axis. So in that case, B would be the solution. However, here we have 1/4 x. What that means is the base is a value between 0 and 1. All right, the base is a value between 0 and 1. When that happens, the graph is a reflection across the y-axis, so to speak. All right, so choice A is the right solution, and I'm going to mark that. When we replace the base with a fractional value between 0 and 1, then the graph is a reflection of the original graph across the y-axis. So A is the correct choice. The other two choices here, C and D, are really a different kind of reflection. Okay, so C and D are not relevant to this particular function. Let's work on question number 2, which says the graph of an exponential function is given. Select the function for the graph from the functions listed. So this time we have a graph of an exponential function given to us, and we have to choose the correct function that goes with it. All right, so we see that this is some kind of transformation of the base exponential function. The base exponential function would look like this, right? So let me pull up the pen here. It would look like this. So it would go up, and then it would go all the way towards the negative x-axis. All right, closer and closer, but not quite touching it. That's how the graph of the base exponential function would look like. We see that the graph given to us in this picture is some form of reflection. It is reflected across the x-axis. It looks like the graph of the exponential function, the base function, is reflected across the x-axis, and that happens when we replace the y values with its negative equivalent. So this is probably the base graph, all right, 4 to the power x. If it is a reflection across the x-axis, as we see in this graph, then it would be negative 4 of x. That means we have negated all the y values, all right, on the positive x-axis as well as the negative x-axis. So C is the correct choice. Let's look at question 3 now. It says write the equation in its equivalent exponential form. So we have been given a logarithmic equation here. We have to write it in exponential form. So we start with the base, whether it is a logarithmic expression to an exponential expression or vice versa. Always start with the base, all right? So the base of the logarithmic equation has a 3 in it. That is going to be the base of the exponent 3. And then a logarithmic expression always evaluates to an exponent. So what we have on the other side of the equation is an exponent. So it will become the exponent of 3 when we put it in exponent form. So it's going to be 3 to the power 4, and then this 81 is going to go to the other side of the equation. 81 is what we get after evaluating 3 to the power 4. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. All right. So let's look for the correct choice here. It's going to be 3 to the power 4 equals 81. So D is the correct solution. Let's look at number 4 now. It says write the equation in its equivalent logarithmic form. So this time they have given us an equation in exponential form. We have to convert it to the logarithmic form. A logarithmic form always starts with log. So start writing with as log, and then the base, all right? The logarithmic the log should have a base as a subscript. So 5, the base of the exponent, in this case 5, becomes the subscript or the base of the logarithm. So log base 5. And then the evaluated value of the exponential expression becomes the argument of log base 5. So we will have log base 5, and then the y will go next to log base 5, and this exponent will go on the other side of the equation equals 3. Again, I'm repeating this, that after you evaluate a logarithmic expression, the answer should be an exponent. It should represent an exponent. So let's see which of these answers match what we found here. Log base 5 of y equals 3 is the first one. So A is the correct choice. Then we have number 5, which says evaluate the expression without using a calculator. Log base 8 of 8. Now we had learned a special property of logarithms which said when the base of the logarithm and the argument are both the same, then the answer is always going to be 1. All right, it's going to be a 1, because if you just transform this into an exponential form, what is going to happen? The base of the logarithm is going to be the base of the exponent, and then this 8, which we often call the argument, goes on the other side. All right, and what should 8 be raised to in order? What exponent should 8 be raised to in order to get an 8 for for an answer 1, right? 8 raised to the power 1 is 8. So 1 is the correct choice. All right. So C is the correct choice. So in other words, when you see that the base of the logarithm and the argument of the logarithm both are the same, the value next to log base 8 is the same as the base, then that means the answer is always going to be 1. All right. Whether this is 8 or 2 or 7 or 100, it's always going to be, the answer is always going to be 1 as long as the two values are the same. Let's work through question number 6 now, which is solving an exponential equation that they've given us here. It says 4 raised to the power x minus 9 divided by 8 equals square root over 4. Now, the first goal that we should have is write exponents with a common base, because if we can do that, then we can make the equations, the exponents equal to each other, and it'll make it easier for us to solve the equation. All right, so we have a 4 raised to an exponent on the left hand side. However, on the right hand side, we just have square root over 4. However, keep in mind that we can always change radicals and rewrite it in exponent form. So how would we rewrite this whole equation with exponents on both sides of the equal sign? So this is how it's going to look. 4 raised to the power x minus 9 divided by 8. This whole thing is the exponent. And then on the other side, we have 4 raised to the power 1/2, correct? Square root means it's a fractional exponent, so it's 1/2. So we have a common base of 4 on both sides of the equation. That means we can just work with the exponents, make them equal to each other, and we can solve for x. So we are going to have x minus 9 divided by 8. I'm just taking this exponent on the left hand side and making it equal to this 1/2 on the other side of the equation, equals 1/2. Right? Now, one way of solving this equation would be to cross multiply. So what I'm going to do is I'm going to multiply, and let me surround x minus 9 with a bracket. I'm going to multiply 2 with x minus 9, and I'm going to multiply this 8 and 1. This is solving by cross multiplication, and this worked when we have denominators. All right. So what we will end up with now is 2 times x minus 9, we are cross multiplying, and then on the other side 8 times 1 is 8. All right, so now it has become a linear equation. We have removed the denominators through the cross multiplication process. So let's just distribute and multiply the left hand side. So it will be 2x minus 18 equals 8. We have to get the 18 over to the other side to isolate the x. So we will have 2x equals 8 plus 18, which is 26. So we'll have 2x equals 26. Therefore, x equals 13. So that's going to be our answer. But you may want to just check, plug in 13 into this equation and make sure both sides are equal to each other. Okay, but we do have a 13 in our solution, which is D, so I'm going to mark that, but let's anyway go ahead and do the cross check. All right, so we have 4 raised to the power 13 minus 9. I'm going to plug in 13 into x. So 13 minus 9 is going to be 4 raised to the power 4 divided by 8, correct? So 13 minus 9 is 4. divided by 8. And let me just make this 4 a little bit bigger so the exponent stands out. And square root over 4 is 4 to the 1/2. So 4 divided by 8 is 1/2. So we end up with 4 raised to the power 1/2 equals. So both sides are equal to each other. So 13 is the solution of this equation. So D is the right choice. Now question number 8 is on graphing inequalities. Okay. So we have been given an inequality here, which is x minus y greater than -2. And we will have to graph the inequality, and actually we have to pick the correct graph from these 4 choices. Now keep in mind that the graph of an inequality is not just a line, not just a point on a particular line, but it is all points about the line, all points in a region about the line. All right. So it's not just going to be enough to draw a line, but we also have to perform a test to see which side of the line we must shade to come up with the right region that will satisfy the inequality. All right, all points in that region will satisfy this particular inequality. We will start with first drawing the line, however. All right, so we will use this inequality as an equation and first transform it and rewrite it in the y equals mx plus b, or the slope intercept form. And then we will draw the line, and after that we will perform a test to see which region, which side of the line we must shade. All right, so let's go through the process here. First, since we have to draw the line, the easiest way is to put the equation in the slope-intercept form, which is y equals mx plus b. So I'm going to write here, the first step is rewrite equation in slope-intercept form. Slope-intercept form, which is y equals mx plus b, correct? That means we have to change this equation and write it as with y by itself on one side, everything else on the other side. Well, we are not really changing the equation. We're just changing the form of the equation. Keep that in mind, all right? So I'm going to start with what we have been given, x minus y, and I'm going to change the greater than sign to equals for the time being, because that way it'll be easier for us to move variables to the other side. So we have x minus y equals -2. Again, I just temporarily, for the time being, change this greater than sign to equals. And then let's solve for y, so that we have y by itself on one side. We'll have minus y. When we move the x over to the other side, it'll become a negative x minus 2. And then once we get rid of the negative by dividing all the terms by -1, or you can also multiply all the terms by -1, both will give the same answer. It'll be y equals x plus 2. All right, so that's our equation. So when we go to draw this graph, we have to, however, go back to our inequality and see what sign, which inequality sign this has. If it is a greater than or less than sign without an equal. So if it's just greater than or less than and not greater or equal to or less or equal to, then just use a dashed line. All right, over here we see dashed line to draw the line. Okay, when you draw the line. So let's draw the line. I'm going to just draw it separately here. I'm going to just get draw a coordinate system. Let's make this 1, make this 2, and then another one 3, and on this side -1, -2, and so on, and on the other side +1, +2, and so on, 3, and so on. All right, so we have here from the slope intercept form, we know that m is 1, so 1 upon 1, right? M is the coefficient of x, so 1 upon 1, and b is 2, right? B is the y-intercept, also called the y-intercept. That means 0, 2 is where the line will cross the y-axis. So let's mark that point here. All right, 0, 2, that's the y-intercept. And then we use the slope information to get another point. So 1/1 means 1 unit to the right and 1 unit up. So from this point 0, 2, I'm going to go 1 unit to the right and 1 unit up. All right, so these 2 points are pretty much what we need to draw the line, get the line by connecting them and extending it on both sides. All right, so it has to be a dashed line again, because, so let's make it a dashed line extending on both sides. Why is it a dashed line again? Because we have a greater than sign and not greater or equal to. So if it were less than sign, you would still have a dashed line, all right, as long as the equals is not included. If the equals was included in our inequality, then it would be a solid line. All right, now that we got the line, we have to figure out which side of the line we must shade. All right, pick any point. All right, so second step was to draw the line, which we did. Draw the line. And then third step is to perform a test to see which side of the line we must shade, whether it's going to be the top part of it or the bottom part of it, of the line. All right, in order to do that, we have to perform a test, an easy test. Pick any point on one side of the line, any one point. To make things easier, pick a point which is easy to work with. On this side, on the bottom side of the line, of the dashed line, 0, 0 is an easy point to work with. All right, so as long as your line doesn't pass through the intersection, XY intersection, just go ahead and pick 0, 0 as your test point. All right, this point has the coordinates 0, 0. So I'm going to perform the test with 0, 0. And how do I do the test? Take your inequality, which is x minus y greater than -2. Plug in the test points into the coordinates 0 and 0 into x and y, and check if your inequality is satisfied, if your inequality is true. So I'm going to plug in 0 for x minus 0 for y. Is it greater than -2? Yes, 0 is greater than -2. So that means this point makes the inequality true. And it will not only be this point that would make the inequality true, it will be every point on the bottom part of the dashed line that will make this inequality true. If you had chosen 2, 0, this point, it would have made this inequality true. If you had chosen 1, 1, this point here, it would have made this inequality true. However, if you had chosen a point on this side, it would make the inequality false. All right. So we chose the easiest value because if you choose 0, 0, x minus y will be a 0. And you can just compare the two values on each side of the inequality and come to a conclusion. So I'm going to shade everything on the bottom part of the line. And that's all. We got our graph. So now we have to just see which of these 4 graphs match the graph we have come up with. So let's look at them. A has the top part shaded, so definitely this is not the right graph. B is what looks similar to what we have here, right? It passes through 2 on the y-axis, right? The intersection point. And then, the y-intercept point is what I meant to say. And then it has the correct region shaded as well. The bottom part of the dashed line, it also has a dashed line as well. These two, C and D, are lines that fall. They are falling lines from left to right. That means they have negative slopes, correct? So these are definitely not the ones. So here for C and D, the line was not drawn correctly. These are falling lines, which means they have negative slopes, whereas the slope we came up with is a positive slope, and that is the correct slope. All right, so B is our correct choice. All right.